in Siena, a perfectly preserved medieval city. Here, human and natural components have coexisted harmoniously for millennia, as evidenced by the landscapes around Siena, world famous for their beauty. Siena and the buildings of the Department of Physical Earth and Environmental Sciences rest their foundations on marine sandstone deposited in an ancient sea dating back to the Pliocene during a time span of 5 to 2.5 million years ago. Perhaps the strong and ancient connection between Siena and the sea has prompted many researchers in our department to the study of the biotic and abiotic aspects of the marine environment. Human activities have affected and continue to affect marine natural systems, both biologically and geologically. All organisms are affected by this impact, beginning with the great iconic species of our sea. These are subject to the impact of micro and macroplastics, as well as that of associated chemicals. By means of non-invasive techniques, we study the molecular mechanisms triggered by the exposure to these substances and their consequences on the health of organisms. Similarly, smaller species that form the basis of trophic networks are also affected. Microalgae, microcrustaceans, and corals. We study them by assessing the impact of emerging contaminants, such as nanoplastics, nanoparticles, sunscreens, and heavy metals. We also study the effects of ocean acidification caused by atmospheric CO2 emissions and the molecular countermeasures put in place by different organisms to deal with them. Furthermore, our researchers study the sea from a geological perspective through micropaleontological, structural, stratigraphic, and sedimentology analysis. This multidisciplinary approach allows us to investigate ancient marine deposits and current depositional conditions, which are often influenced by anthropogenic activities and are responsible for dramatic phenomena such as coastal erosion and salt wedge intrusion. Our research is not limited to the marine environment, but also includes the surrounding environments. Caves are an exceptional document of the past, and their sedimentary fill contains traces of ancient humans. Our researchers study them archaeologically, geologically, anthropologically, and zoologically, providing essential information for understanding the lifestyle of our ancestors. This information is combined with the findings from caves and shelters far from the sea, allowing the detailed reconstruction of the paleo environments and of the earliest history of humankind. Continental environments whereby geological processes interact with human life on a daily basis are extremely dynamic. River floods, earthquakes, and volcanic eruptions are only examples of the most prominent geological events that interact with our life on Earth. The activities of our researchers provide information not only to better understand the mechanisms of these phenomena, but also to propose solutions for the mitigation of their effects. This is essential for a rational and sustainable land management. In this territory, our malacologists study several species of terrestrial mollusks, both native and alien, among which they have recently discovered a new species, a snail, belonging to a not very common family present in East Asia and Australia. Human activities are often the cause of major disturbances, as in the case of bees, valuable pollinating organisms whose populations are threatened by the massive use of pesticides and other chemicals. Fortunately, the natural environment is rich in resources. Our researchers who study the valuable therapeutic properties of plant active ingredients on human cells know this very well. Our research also includes the most remote areas of our planet, such as Antarctica. Here, geologists study glaciers and ancient rock successions, documenting an unexpected past in which Antarctica was home to lush forests, as evidenced by the recent exceptional discovery of a fossil forest. Special mention goes to the research conducted on Antarctic meteorites that provide essential information on extraterrestrial geology. At the same time, our ecologists monitor anthropogenic impacts on these remote and fragile ecosystems, also in the light of climate change. We analyze problems caused by human activities, but we also study possible solutions, such as removing organic and inorganic pollutants from water through nanostructured materials and nanocomposites, produced through a safe-by-design approach, so we can be sure to get highly efficient and environmentally safe materials. In a world where resources are increasingly precious, the department is committed to finding sustainable solutions. Circular economy is not just a concept, but a reality that we pursue every day through innovative studies. We focus on reusing, recycling, and on waste reduction, turning what was once waste into valuable resources. This approach not only safeguards our planet, but opens new avenues for a more sustainable and responsible future. While rainfall on the planet alternates between increasingly violent and destructive phenomena and scarcity of water leading to worrisome droughts, there is one kind of rain that never stops hitting us. It is that of cosmic rays. Some of them are shielded from Earth's atmosphere, so their direct observation must take place at high altitude. That is why some physicists of the department, in collaboration with Japanese and American colleagues, have installed a special eye aboard the International Space Station to see what this radiation looks like, study its composition, and investigate its origin.
The engines igniting, the solid rocket boosters, and liftoff.
Quarter monitoring. We're listening on 2, Chell.
Its name is Colette, and thanks to a sophisticated set of detectors, it allows scientists to measure the energy, trajectory, and charge of particles reaching the space station from space, providing an important contribution to understanding the mechanisms of cosmic ray propagation and acceleration, as well as searching for footprints of the possible presence of dark matter. Despite the Earth's atmosphere screens most of the radiation from space, the study of cosmic rays is also possible from the ground in an indirect way. In fact, the primary radiation that reaches the atmosphere interacts with it and generates extensive swarms of secondary particles that manage to reach the Earth's surface. Although they lose much of their initial energy, the eyes, in this case, are large diffuse telescopes, usually installed in the darkest places on Earth. For example, the MAGIC telescope, installed at an altitude of 2,200 meters on the island of La Palma in the Canary Islands, is joined by physicists of our department. Its purpose is the observation of very high-energy gamma rays of extragalactic origin, aiming to understand the origin of cosmic rays and the presence of gamma sources close to our galaxy or even farther. Another tool for doing research is provided by the Siena Astronomical Observatory. Thanks to its small telescope with a diameter of 30 centimeters, it is able to observe the night sky in the southerly direction from Siena. In addition to educational outreach activities, the observatory contributes to scientific research in the areas of asteroids, variable stars, and extrasolar planets. Despite its small size, it has so far discovered 2 of the more than 5,000 extrasolar planets currently identified. Observation of space from Earth and from the sky would not be possible without the use of sophisticated detectors and sensors that require a continuous evolution. A group of researchers is working to develop state-of-the-art detectors capable of reaching the highest energies yet unexplored. Particle detectors are being developed not only for space, but also for experiments at accelerators. Experimental physicists of our department participate in 2 of the major experiments at CERN's Large Hadron Collider, CMS and ATLAS, which discovered the Higgs particle in 2012. Proton-proton collisions at very high energies are studied at the Large Hadron Collider with giant experimental apparatuses. Researchers from the department also participate in small-angle measurements with a dedicated apparatus called TOTEM. The department at the University of Siena is a crossroads of discovery where curiosity and passion drive every step into the future. Inside this gem, set in the heart of Tuscany, history and the future intertwine in the alleys and squares. Here, the university is not only a place of learning, but a meeting point between past and innovation, where every research and discovery is interwoven with the vibrant fabric of this city. In this context, Siena continues to be not only a witness to history, but also a major player in the arena of science and innovation, confidently projecting itself into the challenges and opportunities of tomorrow.